Welcome to the third and final video within the EEAST video tutorial sessions. Video 1 focused on the input worksheet, Video 2 on the financial assessment, and this third and final video will focus on the results. Within this results worksheet, there are several graphs displayed. The graphs on the left focus on the payback periods of several different variables, while the graphs on the right give a detailed cost-benefit analysis of each scenario considered. Focusing on the graph in the top left-hand corner, potable water savings, gallons per month. In the legend, you can see that these are scenarios 1, 2, 3, 4, and 5, laid out similarly on the x-axis. It can be seen that scenarios 4 and 5 far outweigh the previous 3 scenarios. This is because scenarios 4 and 5 utilize composting toilets. Composting toilets use 0 water in toilet flushing, therefore are going to save the most potable water. It can also be seen that rainwater used for irrigation, scenario 2, saves 0 water. This is because in our input page, we depicted that there is 0 irrigation area. Energy payoff in years. This energy payoff is based on the water energy nexus, as well as pumps and pipes. The water energy nexus simply states that it takes energy to treat and convey your water from a centrally provided source. Knowing this and decentralizing our source material, we can expect energy payoffs. CO2 payoffs. This graph analyzes the carbon emissions and greenhouse gas implications of implementing these scenarios. For this graph, we use life cycle analysis tools in order to take into account implementation to construction and utilization phases. Cost payoff in years. This is what most users will be most concerned with. It can be seen that composting toilets pay off the soonest with 1 year, and that rainwater harvesting systems used for toilet flushing pay off in 44 years, just a little over half of the useful life of the building. Total cost at the end of the building life. These costs are displayed in order for the user to understand how much at the end of the useful life of the building they would have spent. These numbers seem relatively high at first glance, but when considering the alternatives of continually paying for your centrally provided system, they pay back and expressed in these time periods. Now focusing on the graphs on the right, these are detailed cost-benefit analysis of different situations you can have for each implementation scenario. The legend shows a loan, investment operation savings with a loan, investment operation savings without a loan, and your standard baseline scenario with no loan and no investments. Each graph can be analyzed to see when each situation would pay for itself. This is when it crosses the x-axis. On this graph, it can be seen that this pays back within the range of 1 to 3 years. The other graphs can be analyzed similarly in order to make the best decision. The EEAST results page has been designed in order to provide as much information as possible for the user to implement or forego any of the scenarios outlined within the model. We hope that this has been helpful, and we hope that you choose to use this educational tool in the best fit way. Thanks again for watching, and appreciate your time.